for staying until almost the end. Thank you. I hope that the suffering in Israel will soon come to an end and the hostages will come back to their families. And without further ado, welcome to hacking secure coding into high school education. My name is Sahar. I was a developer for many years. Almost 10 years ago, I switched my career path into cybersecurity. My drug of choice is snowy mountains.
Hi, everyone. My name is Yariv Tal. I'm a seasoned developer. I lectured in universities, I mentored in boot camps, and a couple of years ago, I became an AppSec researcher. My drug of choice is roller coasters.
So why do we care? Why hacking secure coding into high school education? Why?
Sorry.
2024, and code is still insecure. The same vulnerabilities appear again and again. Yariv, are we still talking about SQL injection?
Amazingly enough, we still are. And SQL injection was first discussed in 1998. It became a part of the OWASP top 10 in 2007, #1 in OWASP in 2013. 2023, we still saw SQL injection in the MOVEit attack. 2024, CISA and the FBI issue an alert. They refuse to see any more SQL injection in code. Good luck to them.
Refreshing, isn't it? And the same goes for accesses, file upload, malicious file upload, and more and more. So what are the current ways of dealing with it? One way to deal with it is hiring an AppSec professional, a Wonder Woman. She has to deal with tools integration, configuration, interpretation. She also has to deal with teaching secure coding sometimes. She's also the security compass of the company, has to say her word in a discussion about the product. A Wonder Woman, isn't it? Another way to deal with it is to use tools. Tools like SAST and DAST and SCA, tools that produce millions of findings. Some of them are true positive. Many of them are false positive. And then you have to dig to find what is relevant and what is not relevant. And this is only if you are lucky and your organization has budget for all these tools. Another way is the security awareness and training. And me, myself, and I, sometimes the organization invite me to a full 60 minutes of awareness. But to be honest, I'm not so sure that immediately after the talk, the developers run to their computers and fix all the vulnerabilities. Sometimes I'm lucky. They invite me for a workshop. Sorry. I like to move. They invite me for a workshop, and then I have 5 or 6 hours. And then I have 2 options. One option is to build a tailor-made workshop, something that responds to the set of technologies of the organization. And then, as my colleagues from other firms can confirm, it's not profitable. The other option is to give them something that is more or less what they need. For example, if they develop Angular, I can give them a workshop with Vue.js. I can promise you, if you do it, it will be the last time that the developers will attend
a security workshop from their own will. So, what can we do?
Well, there is some good news. In the past couple of years, we've seen new languages that try to handle secure coding as part of the language. Everybody here, I'm assuming, has heard of Rust, trying to get rid of memory management security vulnerabilities. Other languages also try to address security issues. For example, Kotlin has some secure defaults. There are actually extensions to Java that add security features. And we have better APIs. We have better APIs that come with secure defaults. We have security embedded within platforms. For example, Jot, originally, by the standard, you can use, instead of signing cryptographically, you can choose to use no signing. But every library that I've been working with for the past couple of years just won't let you do that. So that's the good news. But the real question is, why do we need this huge ecosystem to handle all of these vulnerabilities? Why can't we just ask coders to write secure code? Why doesn't it work? And to give you an idea, my son is in high school somewhere in Israel, and he's been learning internet programming, otherwise known as web programming, and they have a login form, and this is what their teacher told them how to do the SQL to authenticate. So, who sees one vulnerability here? Okay, come on, participate.
Raise your hands.
Raise your hands.
You can raise your hand more than once.
2 vulnerabilities. 3 vulnerabilities. Not a lot of hands there. Well, this actually has at least 3 vulnerabilities that we could find. Okay, so the first one, who wants to shout it? Shout. SQL injection, yes, everybody knows SQL injection, right? Well, we're supposed to know it, but it has SQL injection. Second vulnerability? Clear text passwords, yes. Third vulnerability, there's authentication bypass here. Because it's like, yes, you can pass % as the password. It will match anything. So students that learn programming aren't taught to code. They're not taught to write code. They're taught to write vulnerable code. This is how they are taught to do it. Now, you can say, okay, we'll teach them how to address this later, but we all know how hard it is to improve on bad habits. It's really, really hard. So it's no surprise that they write vulnerable code. This is what they are taught.
So even before this confirmation, we realized that we have to shift all the way to the left, to the beginning of time, before the developer became a developer. So, how did we hack secure coding into high school? First of all, we got a partner, a friend of us, who knows the domain perfectly, and a teacher. He gave us an access to his Google Drive. 300 teachers, computer science teachers, enjoy this drive when preparing for their class. And then we decided to change the materials. We decided to, we tried to add the security concept into the current lessons, but we didn't advance very quickly. We also worked for our living. So at one point, our friend, Gail Ram, the teacher, the great, great teacher, told us, come to my high school. Please give workshop to my students. And that's what we did. We prepared a skeleton for his students. They coded. They hacked to their solution, not something that we created. They hacked to their solution. They fixed their solution, and they were very happy. And also the teachers were very happy. They were so happy they started to spread the word about Secure from Scratch everywhere in the WhatsApp groups of teachers, and teachers from all over Israel started to invite us to their school. It was great because it was after October 7, and we felt very good that we can do something for a living, more or less, but also give something to our country. So they told us about the Geffen program, which aims to provide equal opportunities for students from all over the country. We registered to the program, and something like a week ago, they accepted us. So next year, it will be much more easier to teachers to invite us to their school. And we also joined their gathering. They had a gathering, the computer science teachers. They had a gathering in Jerusalem this week. So we gave the workshop to the leading teachers. We got a lot of feedback, a lot of good advice how to reach our goal that right now is in the sky, which is change the education material and to add the security concept to every computer science book, every programming book.
So, before we continue, there's a QR code here for a poll we are running on LinkedIn. Do developers need to know about OWASP Top 10? We'd be happy if you could scan the code and give your opinion on this poll. We'll publish the results on Friday. That's tomorrow, right?
Yeah.
I have my own personal opinion. You'll probably understand what it is on the next slide. But I'm going to talk about how do we build workshops that high schoolers like. And high schoolers are very much like developers in that they want us to cut to the chase. They don't want a lot of theory. They don't want buzzwords. They don't want acronyms. They don't want to hear about all the types of vulnerabilities. They want to work on the computer as much as possible, be interactive as much as possible. So the first thing we do in our workshops is we focus on coding. We don't focus on analyzing the code. We don't focus on teaching them find the vulnerabilities or things like that. We focus on coding. I have to remember this. Yeah, okay. So the second thing is, in order to save time, we look for a simple yet real-world scenario. For example, we take a trivia program like Kahoot, simplify it, because they're high schoolers, we might even simplify it to a level where there's no networking, and give them something that it's like a trivia program. They can easily understand the domain, they can easily understand the code. We also give an initial skeleton code that they can immediately compile and execute. This allows them to start working immediately. They don't have to start from scratch. They don't have to write a lot of code before they can see the results. If our goal is for them to implement a feature, we'll give them a mock-up of the feature so they can execute it, see that it always returns the same hard-coded output, and then implement the feature by themselves. If our goal is to let them have some experience in hacking, they can execute the program, try to enter invalid input, see that they managed to hack or don't manage to hack the program. They don't have to wait with that. Then what we do is we make this in phases. Each phase, we highlight the security problems. They suggest solutions. They go and implement the solutions. Again, we highlight the security problems in those solutions. Usually, because they're high schoolers, all of them will give insecure solutions to the problems. By the way, with professional developers, it's not much better. 11 out of 12 developers will give an insecure solution. That's our own statistics. So again, we let them suggest solutions. Eventually, we show them a secure coding alternative. We explain why the secure coding alternative is better, what's the mentality that makes it better. And then we suggest infrastructure, turning this secure code into infrastructure so they don't copy paste it every time. Instead, they can write a function, a class, a singleton. The problem is there's a lot of material about secure coding. We can only give them the tip of the iceberg. So what we also do is we tried to condense the principles behind secure coding into a 7-letter acronym. We call it PREVENT.
So PREVENT. P is for priority, permissions, and privacy. 2024, we have to put security as a first priority. R for reporting and logging. We have to think what we want to log, what details we should include in the log and what we shouldn't, and what we choose to report and what we don't want to report. E for easy to use, securely, easy to use safely. Staff this morning mentioned the file upload. In every programming language, we have the file open method. And this method is vulnerable by design. What if I want to create an infrastructure that is easy to use safely? Then I'll create a file open with a directory parameter. And then I'll make sure in my infrastructure that the file that the user wants to open belongs to this specific directory. Verify refers to maybe Stack Overflow, RIP. Now it's generative AI. So we have Gemini and ChatGPT and a Copilot. And believe me, I tried. I have a full workshop about generative AI and if it's secure or not. What do you think? Who think it's secure? Nobody. Okay, thank you. Thank you. Refreshing. Verify also refers to code review. I believe that most of the developers conduct code reviews. Just add the secure part to this process. And errors. We have to deal with errors and exceptions. Sometimes just to save the resources and to protect ourselves from denial of service. Sometimes other vulnerabilities, we have to log the exception for sure. Neat code, security by clarity. I think that nobody thinks that spaghetti code will protect us from hackers. Also, the generative AI can help us with this as hackers. We can give the generative AI all this spaghetti code that we don't understand, and it'll help us with that. But if our code, our own code, is spaghetti code, we will never be able to spot the vulnerabilities. So security by clarity. T for trust boundaries. Whenever we move data or control between entities with different trust level, we have to take proactive actions. It could be sanitizing, verifying, do something. Maybe throwing an exception.
Yeah. So these principles, they sound very basic, but surprisingly, not many developers are aware of them. You'd be surprised how many developers are not aware of logging, for example. But can we also help existing professional developers do workshops?
Yeah, I believe we can. But as I said before, if we are the security professionals, create a tailor-made workshop for every customer and customer, we will not be able to make living. From the other end, I don't want to give the developer something that they don't like. So that's why we created a GitHub repository. In this GitHub repository, there are workshops, labs, skeletons for labs for high school students, but also for professional developers. And I hope that all the security professionals will join us and develop together a repository that can help us to give the best experience that we can give to our clients. So what can you do? You can share an idea for a scenario. You can develop a lab. You can also conduct a code review. You can create walkthrough. It could be recording, it could be textual. And also, if you don't have time, and believe me, I know, we don't have a lot of time. If you use a lab, please share your feedback. It could be very, very useful.
So, one more.
And the most important thing, spread the word about Secure from Scratch.
Right.
Tell your friends, tell educators, tell your mother.
Okay, so let's summarize. 2024, and it's not surprising that we see the same vulnerabilities again and again. Developers are taught to write vulnerable code. It's not just in high schools. I've seen the materials in universities, I've seen the materials in courses, I've seen the materials in boot camps. They are taught to write vulnerable code. This is what they are taught. So it's not surprising that this is what happens. We need to shift all the way to the left, okay? We need to start with that material and make it secure. Hopefully we will be able to do that in high schools and everywhere else. But we also need to help existing developers, and you can help us there. You can join us in the open source because, like Or said, it takes a lot of work to develop workshops. We can't develop workshops for all technologies, for all interests. We need help. Questions? Yeah, go ahead.
So, from what I understood from your talk, all in all, the idea is to teach first high school and general developers patterns and storage anti-patterns which are insecure. But all in all, you're trying to make these workshops that you can verify are secure. But how can you do that? How can you verify that the workshops you give are secure and all the others aren't?
Great question. Yeah, we'll repeat. Okay, so it was a long question, but the gist of it is, how can we make sure that the workshops we create are secure? You want to answer that, Alan? Okay, so first of all, we can't, okay? But we bring our experience, we bring what we've read, what we've learned, and we write code using secure principles. The problem is no one can be sure that once you write code using secure principles, it will be secure, because you can never anticipate what kind of hack will be found. 0-day, maybe you're using a library that you think is very secure, or an algorithm that you think is very secure, and 10 years from now, you find out it's not secure. We have no idea. So we hope that we know that it's more secure. We know that it's, at least with secure principles, you can never be sure.
I will add to that we talk about welcome list and block list. And the best attitude, we believe, is welcome list. And if we teach the students what we want to achieve, what we want to build, it's much better than the current attitude, which is to tell them how not to develop. Because most of the product, they ask the developers to hack something, and then, okay, don't do that and don't do that. We want to teach them something else. We want to tell them what to do, not what we don't want them to do.
Yes, and I'll add to that, even though that would mean we don't have time for another question. We don't teach anti-patterns. We try not to. They usually have the anti-patterns already. We try to teach directly the correct way. For example, we think it's wrong that you're taught in high school to use random, because random is not secure. And why not use secure random or secrets if you're using Python? Go for it. I mean, okay, you have efficiency problems. Efficiency can be measured. You can find out that it's not efficient. You cannot measure that it's not secure. So it's better to start with students, teaching them only the secure stuff. If there's an alternative, go for the secure. If they have an efficiency problem, they'll Google it and find that there's an alternative, but it's not secure, but it's more efficient. Fine. But go and teach only the secure stuff. That would be much better. Like with the SQL, don't teach that you can concatenate string. Go for directly for parameterless query. And time's up.
Time's up. So thank you so much.